So in our previous videos, you were given all resistance values on your resistors. In this circuit, it's going to be a little bit different because what I want you to notice is that I gave you voltage information, current information, and resistance information. As such, it's not a straightforward way to answer like it was in the previous question. So what we need to do is we need to keep in mind our rules, okay? And if you look back to the cheat sheet, we know we've got two types of circuits, series and parallel. And we've got voltage, we've got current, and we've got resistance. Now in a series circuit, voltage adds up, but current remains the same. And with resistance, it adds up. The opposite's true in parallel, where voltage is now equal everywhere, current adds up, and resistance is the reciprocal. So with that in mind, we need to take a look at what we've got. Now we've got a mixed circuit of series and parallel information. So the first thing I do when I get a question like this is I draw on my pathways. So in this particular case, we've got our red electron pathway, and it goes this way. Another example we can use is the blue electrons. So the blue electrons are in this case not going to take the inner pathway, but are going to take the outer pathway. Whenever you're struggling with these questions, my first piece of advice is to draw on the different pathways and look at how the electrons flow. From here, it's a matter of using that chart from your cheat sheet that we just showed on the left-hand side of the room and trying to figure out how to solve this. Now, there are multiple ways in which you can solve this. You may approach this problem completely differently than I would. This is just the way it occurs to me. So when I look at this pathway, I'm going to focus first on the blue pathway. Because I can see the blue pathway, it goes through two resistors. This resistor right here, which is 1 ohm, and then the second resistor where we spend 10 volts. Now we know in a series circuit that voltage adds to add up. So therefore, if you start off with 12 volts from the battery, and you're spending 10 volts at the second resistor, therefore you only have 2 volts that you could spend at this resistor right here. So 2 divided by 1 makes this 2 amps. Now, if we look at the red pathway for a second, yet again, we've got $12 to spend. We know we're spending $2 at the first resistor, 6 volts or 6 volts at the second resistor, which brings us to 8 volts. Therefore, we only have 4 volts to spend back at this resistor right here. And yet again, we know 2 pieces of information. We're going to solve for the third, which makes this an 8 ohm resistor. We also know that these two resistors here are both in series with one another. Therefore, if the current of the second one is a 0.5, it has to be 0.5 amps here as well, which makes this 12 ohms. Our last resistor right here. We know that we have 2 amps along here, and 2 amps represents blue and red electrons. Therefore, we have to have 2 amps right here, which makes this the resistance of 6 ohms. Now, if we've got 2 amps between our red and blue people, and we know 0.5 of them are red people, then by definition, 1.5 of them have to be blue people. So when we try to work out this piece right here, 10 divided by 1.5 works out to be 6.67 ohms as your resistance.